Alrighty, it looks like I forgot to do yesterday's problem, and I will do it now. It's going to be easy. Unfortunate. Fortunate. Whatever. Minimum pair removals to sort array. Part 1. Given an array answers array nums, you can perform the following operation a number of times. Select adjacent pair within the minimum sum in nums. If multiple such pairs exist, choose the leftmost one, replace the pair with their sum. Return the minimum number of operations needed to make the array non-decreasing. Non-decreasing. Array is said to be non-decreasing if each element is greater than or equal to the previous element. Okay, so minimum pair, so I think minimum is going to be 3, 1. So that's replaced with 4, so it's 5, 2, 4. 2, 4 replaces with 6, so 5, 6. And then 5, 6 replaced with 11. No, 5, 6 is non-decreasing. So 5, 6, which is 2 operations. 1, 2 is replaced with 3. 3, 2 is never going to be... No, 1, 2, 2 is already fine. Interesting. It's not a very long number, not a very long array. I think it's this. I'm going to try brute forcing it. I think well, there should be a faster way than brute forcing it, but brute forcing it does seem pretty enticing. How bad could it be? So it'd be like 50 operations, maybe 50 times 50 if I do an n squared technique. I mean, yeah, let's go ahead and try the brute force. Each pass I need to check if it's non-decreasing. If it is non-decreasing, just return it. If it isn't non-decreasing, then I have to do the operation, right? So let's say while true, maybe. Yeah, while true. So I need to do a full pass each time in order to see which one is the lowest. I think I need probably the array is going to change each time. So I'll say here n is the length of nums, and I'll have an empty array of the new values that I might make. I'll keep track of the min index for every index in range n. I guess n minus 1 since I need to compare n versus n minus 1. I'll have a boolean can keep track of if it's decreasing. Let's see. I'm gonna assume it's non-decreasing and then set the flag to be true if I see it to be decreasing. So I'll say decreasing flag is going to be initially false. So I assume it's non-decreasing. Okay, so let's change the flag if I see it's decreasing. So if nums at index is greater, if it's decreasing, right? If it's less than nums at index plus 1, decreasing flag is set to true. And then min index is going to be the index of the, I guess there should be min index and min sum. I'll set this to be initially infinity, I guess. If nums at index plus nums at index plus 1 is smaller than the min sum, then I want to store this index. So min index equals this index. I think that's all I need to do. Okay, and then if, oh, before I forget, answer plus equals 1 after this. If decreasing flag, if not decreasing flag, which means that it's all good, then I need a break. Return the answer after I break the loop. Otherwise, I need to actually modify this array, right? So for every I guess I just need to modify index and then move everything else up and then pop, something like this. So like actually I guess array is not necessary then. I'll eventually do nums.pop for uh, I guess it should be something like nums at index equals nums at index plus nums at index plus 1. So replace that spot, and then for every index in range, oh, so this should be nums at min index. For index in range of min index plus 1 to n, I guess it should be maybe n minus 1, because I'm going to modify that spot with the next spot. Nums at index is equal to nums at index plus 1. Okay, let's see if that works. That did not work. Let's go ahead and print out what's going on here. So first pass, this should do 5. So replace the 3, 1 with a 4. That's good. Next pass is 5, 6. So it should have returned there 5, 6. If it's an array said to be non-decreasing if every element is greater than or equal to. My logic here is incorrect. Decreasing flag, so if nums at index plus index is greater than. My poor faulty logic. Okay. So I don't think this is very good in terms of optimization. Okay, it's not even good in terms of completeness. Correctness. Ooh, negatives. I don't think I took that into account. Did I? Okay, let's see. Well, I need to actually add this to my test cases. So maybe I should add the loop that this is in. Okay, so first pass it should replace the -1, 3, no, 3, -2. That adds up to 1. This is the smallest, adds up to -1. So I should replace that with -1 at the end. Okay, I did. And the next pass, it should maybe combine the -2, 2 to 0. It didn't do that. What did it do? It combined the 1, -1. Oh, okay, so I'm not storing the minimum correctly. So if nums is plus this is less than the min sum. Oh, I didn't even store the min sum. Great. Wow, that's so bad. Okay. Question is if this works, whether or not I need to consider trying to optimize this. Yes, I would like to complete. I have 4 incomplete challenges already. Fuck me. Okay, 3 incomplete challenges. Okay, so I want to try to find a better way of doing this. It is easy. Maybe there's going to be a medium or hard version of this. What is the better way of doing this? Better way of doing this would be to just have a flag on indices that are have a flag for indices. Actually, maybe just to have a stack, a queue. The queue is not going to work. So somehow flag the indices that combine, store the addition, and then flag the next index as not used. Doesn't quite work, because then when you do the next pass, you'd have to figure out if they're, when you're trying to add, what the falling index is. I mean, maybe you can store the list from every index what the falling index is. That might work actually. Then you don't have to check. You store a list of the index for every index in the array. You store a list of what the next index is. There has to be a better data structure for that, right? Return the minimum. Multiple such pairs exist. Choose the leftmost one. Guess you could just, I think maybe it makes sense to do a decreasing index loop rather than an increasing index loop. I don't think so. I don't think so. The sum, and I feel like it has to be n squared. Is there some logic to determine? Is there some logic to determine? Five, two, three, one, 3, 1, 5, 2, 4, 2, 4. Has to be non-decreasing. Non-decreasing. So 5, 2, 3, the 2, 3, 1 has to combine at some point. pass, you see what the lowest is. Combine the lowest, you modify, do another pass. Non-decrease. Array set to be non-decreasing if each element is greater than or equal to the previous element. What if you kept track of the number of non-decreasing pairs, and then you modify that count each time you do a change? And then you have a heap. You have a heap of pairs, a heap of adjacent pairs and their sums. If you kept a tuple, kept a heap of tuples where the tuples were the sum of two adjacent values, the indice index where they are. But then once you do that modification, then there's going to be a tuple that's outdated based on that, right? There's actually going to be two tuples that, so, or there might be one or two tuples that are outdated. So if I said something like 5, 2, 3, so I have a heap that is like 7, index 0, 5, index 1, 4, index 2. And so I do the replacement for index 2. So that becomes a 4. But then this makes the 2, 3 becomes a 2, 4. So that should be 6 index 1 now. And the 5 index 1 needs to be replaced. So 5 index 1 is outdated. But then if there was another value, so let's say this is like 10 here, and there's like 11 index 3. 4, 2 being replaced makes 5, 1 should be replaced with 6, 1. And 11, 3 is replaced with 14, 3. 14, 3. So complicated. Okay. I'm going to go ahead and just say I want to actually do the other daily today, which I think is hard, but regardless, so I think I'll just say here, definitely not optimal solution, but I'll force myself to find it if this comes back up. This problem comes back up in medium/hard version that requires that solution. Think maybe think there might be a sorted kind of heap version, heap solution that would use O of n log n rather than the old kind of n squared that this solution does. The above is pretty much a brute force solution that iterates over all adjacent pairs, has a flag to check if the end condition, which is all values are non-decreasing. Is satisfied. If so, return immediately. If not, keeps. If not, uses the tracked min index, where min sum of adjacent values is found, and kind of and edits the array to make that sum at that index, bumping up the later values. Loops that until the end array is found. Time complexity, this can be O of n squared, since each loop might have to edit the array, which will take O of n time. So outer loop is n, inner loop is n. Space complexity, this can be O of 1, since we're modifying the array to each pass, rather than using a different array. Alright. Oh, there's someone. Part 2 of this problem.